This is the third video to section 3.4. In this video, we're going to work more with the domains of the composition of functions. Whenever we are considering the inside function, we must consider its domain because that will very likely affect the outcome of the domain of the composition. Let's take a look at what I mean here in number 5. So please notice f of x is x squared plus 4. This time g of x is the square root of x minus 2. Now the domain for f is all real numbers. It's a polynomial. However, the domain for g is different. We cannot have a negative under the square root. Therefore, the domain for g will be 2 to infinity. Now, let's go ahead and do our composition here. We're going to plug g into f, and we're going to plug in root x minus 2 into f. And we'll get this, and we'll get x plus 2 for an answer. Now, normally the domain of x plus 2 would be all real numbers. But since this is an answer to a composition of functions, we know that the domain of g was 2 to infinity. So no number less than 2 will be going into f here. So our domain for this composition of functions will still be 2 to infinity. Moving on to number 6, we're asked to find the f of g and the g of f. Before we begin number 6, let's look at the domain of f and the domain of g. For f, we are not allowed to have 0 in a denominator, so we don't want x to equal negative 3. And for g, our domain will be all real numbers but 0. So we want to keep that in mind as we're doing these functions. So first, let's look at the f of g. Let's recall that this is the same thing as f of g of x, which means we are going to plug g into x. And we'll get this. Now, this is a complex fraction, so let's multiply both the numerator and the denominator by x. And when we do that, so we have to find out what the domain is for this function. Now, for this answer here, we do not want the denominator to equal 0. So we must take that into consideration when we solve this. So x is not allowed to be 2/3, but please remember that x also cannot equal 0. So our domain for this composition of functions we only had to be concerned about the domain of the inner function, in this case g, and the domain of our composite function here at the end. In this case, we didn't have to worry about that x cannot equal negative 3, but we will in the next part. So for the next part of this problem, they ask us to find the g of f. Now, this time, f is the inner function. In order to deal with this complex fraction, we'll multiply both the numerator and the denominator by x plus 3. So we'll get this. Now, normally for this function, the domain would be all real numbers. However, recall the function that was the inner function. That inner function was f, and for f's domain, we are not allowed to have -3. Therefore, we're not allowed to have -3 for the g of f either. So that means our domain for the composite of these two functions will look like this. And that's the end of the third video to section 3.4.